Okay. All right. Hello, everyone. My name's Danny. I'm the president of Neuroscience Research Group, and just want to welcome you all, and thank you for coming. And quickly, just want to thank our executives, Deepta, Philip, Andrew, and Abdullah, and Ali, our vice president. And before I introduce our guest, I just want to say that when you want to ask a question, please write in the Zoom chat, I have a question, and we will let you ask your question in the order that your comment appears in the chat. And yeah, Ali's going to be in charge of that, so she'll unmute your mic. So just to kind of reiterate, if you want to ask a question, say, I have a question in the chat, and we're going to go through it in order and let people answer their questions like that. So, yeah, we have Dr. Donald Hoffman with us today. He was kind enough to join us. I know he's in high demand, so we really appreciate you coming. So Dr. Hoffman has been studying cognitive science and perception for 30 years and written many papers and I believe two books, right?
Three.
Oh, sorry, 3 books. And the new one is amazing. I read it. I recommend it to anybody. It goes really in depth, but it's like easy to follow along as well. So yeah, I recommend that to anybody. But yeah, so let's just get started then. See if anybody has a question.
If anyone wants to just write their question in the chat too, if they don't want to say that aloud, that's more than welcome as well.
So, I have a question. So some mathematical equations are really just approximations, right? Like at the end of the day, like turbulence equations and all that stuff. And if the brain functions chaotically, right, like a turbulent fluid or whatever, then would we only ever have approximations for understanding the brain, or would we ever actually gain like a causal story of what's actually happening?
Well, right. So you can have very simple equations that lead to chaotic behavior, right? So in some sense, you understand what's going on because you've written down a very simple equation, right? And so in that sense, you understand what's going on, but you can analyze the equation and show that it has very, very sensitive, great sensitivity to the changes in the initial conditions. And so it depends on what you mean by understanding, right? And we can understand chaotic systems in the sense that we can write down mathematical equations. We can, find attractor states and so forth. But we also understand, in some sense, how they will lead to unpredictable results, based on changes in the initial conditions. So yeah, if you think about any feedback system, almost is going to have the tendency to have chaotic behavior at some point. And clearly, the human brain is a feedback system. It's got all sorts of thalamocortical loops and so forth that are going on. So there's all sorts of feed forward and feedback pathways in the brain. So yeah, you can imagine chaotic behavior happening. But I know people in chaos theory don't just throw up their hands. They go and try to study the equations, and so we can do the same thing with the human brain.
Do you think we can come to predictions based on these equations then? Predictions on human behavior or how they're going to perceive an object or other kinds of things if the theory gets advanced enough in the future?
Yes, we can make predictions, but they're going to be probabilistic, right? Whenever you have chaotic behavior, at some point, the best you can do is make probabilistic predictions. And the same is true of brain network behavior, right? We're only going to be able to make probabilistic predictions. But those are usually good enough, and we can test probabilistic predictions because we can run experiments many, many times and just look at the frequencies and sort of see if we're getting some confirmation of the probabilities that we've predicted. So yeah, I think that if we're happy with probabilistic behavior and probabilistic predictions, then we can absolutely do it. And it's not just in the case of human neuroscience and human cognition that we are stuck with probabilities. Physics itself is stuck with probabilities. So this is nothing particularly special about neuroscience. We can't even predict specifically what an electron's going to do, much less the whole human brain. So that's sort of, nothing to see here, and nothing special to see here in neuroscience with that regard.
Could you explain a bit what a conscious agent is?
Right. So I'm very interested in trying to get a theory of consciousness on its own terms. So there's a lot of work being done in cognitive neuroscience right now to understand consciousness and its relationship to brain activity. And so there's a lot of theories of consciousness out there. But when you look at the theories, they're theories of the following type. They're, for example, integrated information theory says, well, we're going to assume that there are these physical structures that have a certain computational architecture. They have integrated information, they have a certain causal computational architecture. And then we're going to posit that consciousness of various types is identical to certain of these architectures, right? So what you're doing is positing something about a physical system with this computational architecture, or global workspace theory. We're positing there something about the architecture of broadcasting data in a computer system somehow, and more widely broadcast information is somehow going to be related to consciousness. Or in the microtubules theory of Penrose and Hameroff, orchestrated collapse of microtubule. We have certain quantum features of microtubules and their coherent collapse. And so in each of these theories, the key thing that I notice in each of these theories is that really what's going on is we're assuming physicalism. We're assuming that space-time and physical objects are fundamental. Causal computational circuits that have certain integrated information. Neural microtubules that have certain coherent electron states and so forth. Or certain computational architectures that have certain kind of broadcast properties to certain bits of information. And then we try to identify consciousness with some feature of those systems. And the spectacular failure of all of our attempts to boot up a theory of consciousness in this manner led me to think we're just starting completely wrong here, right? By spectacular failure, let me be very, very specific. What I would mean by a interesting success would be if one of these theories could predict precisely one specific conscious experience, like the taste of mint, or a particular color red 55, something like that, right? And say in the case of integrated information theory, said this is the precise causal computational architecture that must be the taste of mint. It could not be the taste of vanilla or the smell of garlic or red 55. And these are the principled reasons why this architecture and this causal computational structure must be the taste of mint. And if you made this change to the circuit, it would necessarily then change to the taste of chocolate. There is not one theory anywhere that can predict even one specific conscious experience. Nothing. So from my point of view, by the way, these are brilliant people. Many of them are my friends. They're certainly colleagues. And I'm glad that they're doing the work that they're doing. So it's fantastic that they're doing this. But we have to look at what we've got, and right now we can't predict one specific conscious experience. That, as scientists, has to give us pause and say, what are we doing wrong here? It's not for lack of trying, and it's not for lack of brilliant people. These are brilliant people working on this, including Nobel Prize winners. Francis Crick spent the last 20 years of his life on this. So we've in effect been trying to boot up consciousness from some physical model, integrated information properties of circuits, microtubules, and so forth. And so I said, well, everybody's trying to start with a physicalist framework. And it's not working. So at least one or two of us, if 99% of us are searching in the physicalist search space, maybe one in 100 should look somewhere else, right? It's a bad search strategy for everybody doing the same thing. So I said, let's take consciousness on its own terms. Let's ask, if I were to just think about what I want from the theory of consciousness on its own terms, what would I do? And you can write down a laundry list of dozens of things, right? So you need to explain qualia, perhaps free will, intelligence, learning, memory, problem solving, the feelings of morals. There's just the hard problem of there's a whole laundry list of things that you could want in your theory of consciousness. And so what do we do when we try to boot up a scientific theory? If I just took my whole laundry list of things that I want in a theory of consciousness and I just throw them all in, I'm going to make these all my assumptions. Well, I've assumed everything. I'm not going to explain anything. I've just put this laundry list down. So what do we really do? We ask, what is the minimal set of assumptions I need to boot up, hopefully, a theory of consciousness that can handle the whole laundry list, right, of all the things that I wanted to explain. So I'm not going to assume all the things so maybe I don't want to assume intelligence. Maybe I don't want to assume memory. Maybe I don't want to assume a bunch of these things. So what is the minimal thing that I want to assume? Maybe I don't want to assume the notion of a self or self-awareness, right? Maybe I want to have the absolute minimal assumptions possible and then force myself to do the work from that minimal framework to build a theory of everything in consciousness. Think in that regard about what Alan Turing did when he came up with a theory of computation. There's lots of things that we compute. There's all the digits of pi. There's the traveling salesman problem. There's all sorts of now you could just start going into the weeds of all these problems and sort of get a messy theory of computation. What did Turing do? He said, I want to get the absolute minimal essence, the almost trivial essence at the heart of every computation. And he did it. He said, imagine that you have a finite set of symbols, maybe just 0 and 1, a finite set of states, and a drop-dead simple mechanism that can only do a couple things. It can read one symbol, change one state, move one step right or left, and write or not a symbol. That's all it can do. Drop-dead stupid. That's all this thing can do. And then it's the theorem, or at least a proposal, the thesis, the Church-Turing thesis, that anything that can be computed in any way can be computed by this drop-dead simple Turing machine, right? And that's the power of the Turing machine, is that it's unbelievably simple, and yet it doesn't leave anything out. And that's what we want in a scientific theory. That was my attitude in coming after a theory of consciousness. Following in Turing's example, I want the minimal mathematical formalism that will do the job, hopefully, of being able to boot up everything that we want to say about consciousness. And so at this point, there's no rules. It's a matter of your creative choices, and then the proof is in the pudding, right? What, in fact, can you do? In some sense, Turing chose what he chose, and it just so happened that he nailed it on the head, right? So we have to, have to be lucky. See if we can get something that nails it on the head. So what I chose to go after was to say, the minimal thing I need are conscious experiences, the taste of chocolate, the smell of garlic, a headache. Conscious experiences. If I don't have those, I can't do anything. So I'm going to start with those. And the one other assumption I need to have is that conscious experiences are not inert. that they do something, right? They cause some kind of action. So I'm going to have some notion of agency that they're, but I want a minimal notion of agency. I'm not talking about a self-awareness. I'm just talking about somehow that conscious experiences inform decisions that can affect other conscious experiences. And so what I wrote down was the notion of a conscious agent. And a conscious agent, I'll say what the mathematical structure is basically you have a measurable space, a probability space of conscious experiences, and a Markovian kernel, which basically says for each experience, what is the probability of taking certain actions to affect experiences of other agents? That's the basic idea of the thing. So there's basically a measurable space of conscious experiences, a measurable space of actions that the agent can take, a decision kernel, a Markovian kernel, and then another kernel which says, how the actions that this agent takes affects the other agents. It's a drop-dead simple formalism. It's only got like 2 measurable spaces and 3 kernels, basically, right? There's a kernel coming into my set of experiences, a kernel from my experiences to my choices, and a kernel from the choices to the other agents, how it's affecting them. That's it. It's as trivial as I could imagine. And so that's what we're working on. But it turns out it's straightforward to show that formalism is computationally universal. Markovian kernels, n by n Markovian kernels are easily shown to be computationally universal. So even though I don't have any explicit notion of learning, memory, problem solving, intelligence in this, networks of conscious agents can be built to do all of those things. It's just a theorem. So I know that anything that we can do with neural networks, I can do with conscious agent networks. That's trivial to show. But what my goal here was to have the minimal formalism of consciousness qua consciousness, the very drop-dead minimal thing, and see if I could then build up the whole theory of consciousness from it, including the notion of self. From this framework, a self is not fundamental. It is going to be among the symbols, the data structures that certain systems of conscious agents build. So from this point of view, and again, I'm not saying I'm right, I'm just saying what this formalism entails. It entails that the self is not fundamental. The self is a story that's concocted by networks of conscious agents, but it's not fundamental. What's not a story is raw experience and raw choice. Now, I'm not saying self-conscious choice. I'm not saying, like deliberation, conscious deliberation and choice. That's going to be emergent from networks. But the raw choice itself in this model actually is not something that you're consciously aware of. All you're consciously aware of are the actual qualia that you've got. The kernel is not something you're aware of, but it's the kernel that's implementing the choice. So this theory entails that you're not directly aware of your choices. You're also not directly of what you're actually doing. You can only know what you're doing under a description, your own. So it has all sorts of remarkable properties that I didn't even understand first when I wrote down the formalism, right? I was just writing down the most trivial formalism I could that would be computationally universal. And then it has all these interesting properties that I didn't expect. So that's sort of what I went after when I was trying to come up with this mathematical model of consciousness. Someone could, of course, say, I don't like that starting point. I think we should start with a different starting point. That I would be delighted. I mean, that's what we're up. That's what science is about. It's about trying to come up with competing models. So if someone says, look, I don't want to start with conscious experiences, I want to start with something else. Or I want to start with a self. Great. The rule of the game is state exactly with mathematical precision what you're doing, and then we'll see what happens, what the formalism does.
Cool. We have some, Ali, do you want to address the questions?
Yes. So I'll unmute you if you'd like to ask your question aloud. Here we go. Oh, wrong person.
Hi. So I have a question of, would that mean that we can't account for consciousness on an atom level? So are you saying that consciousness arises from atoms? And this is what the conscious agents come from? Is it based on atoms and energy? Is that the source of it?
Great question, and the answer is no. So the idea is just the opposite. So almost all of my colleagues would be saying that's like a panpsychist point of view, right? Where you say that in some sense at the fundamental level of atoms and electrons and so forth, each one of them might have a fundamental unit of consciousness or something like that. And so we can start with an atomic notion of consciousness in a panpsychist kind of thing. And I'm saying that I want to let go of space and time and atoms entirely. Nothing inside space-time is involved in this. The theory of conscious agents is entirely outside of space and time. It's its own framework. And what that means is I'm going to have a dynamics of conscious agents that's a dynamics on a graph. So this can be a network, right? Think of it like the Twitterverse, right? Think of the Twitterverse as this vast social network, and I'm proposing that there's this vast social network of conscious agents that are influencing each other. Like in Twitter, you tweet and you follow, right? And so the idea then would be that what are space and time? How do they relate to this vast social network of conscious agents? It's like a visualization tool. So space and time are like a visualization tool in the following sense. So suppose you're a Twitter user and you're trying, there's tens of millions of Twitter users, literally billions of tweets and scores of things that are trending. There's no way for you to read all the tweets or interact with all the users. So if you want to understand what's happening in the network, what's happening in Toronto versus LA, what's happening in all of the United States versus what's happening in Guatemala, right? You would like a visualization tool that somehow takes all the billions of tweets, all the things that are trending, and packages it in a simple format that you can just sort of look and go, oh, so that's what they're interested in Toronto. That's very different what's happening in New York or what's happening in San Francisco. And so you have this visualization tool that takes billions of tweets, all this, the tens of millions of users, and compresses that down and gives you the essence. But also then if you want to see what Joe is doing at at NYU in New York, you can actually go to Joe's room and interact with Joe, right? That would be the kind of visualization tool you want, that lets you to zoom out and get the big picture, or zoom in and interact with an individual Twitter user. That's what I'm claiming space-time is. It's a virtual reality headset that's a visualization tool. So space and time, and this is really hard for us to wrap our heads around because it's so counter to everything that we've been programmed to believe. We think that space and time are fundamental and physical objects are the fundamental nature of reality. I'm saying, no, this is just a little VR headset that we have on. It's a visualization tool. The reality is this vast social network of conscious agents, and we've mistaken our little visualization tool for the truth. We've assumed that it's like a person who, you put on the VR headset and they start using it to see the Twitterverse, and pretty soon they say, there's no such thing as a Twitterverse. What really exists are just the things I'm seeing right here, all the pretty little candy icons that I'm seeing. That's the reality. That's what physicalism is from my point of view. We've mistaken the headset for the truth, but the headset is just a visualization tool. So from that point of view, so it's one thing for me to say this and it's all highfalutin and so forth. Here's where I have to do hard work. If I'm saying that atoms and quantum theory and general relativity and so forth, that these are not fundamental, that this network dynamics of conscious agents is fundamental, then I have a project that I have to do to prove that. I have to show how the network dynamics of conscious agents first can give rise to space and time. I have to show how the structure of space and time can arise. And in that structure, I have to show how the properties of quantum theory arise. If I can't show that the dynamics of conscious agents projects into space-time and looks like quantum theory and general relativity and evolution by natural selection, then I'm wrong. So this is not just a hand wave. I actually have serious work to do. And that's, in fact, what I'm spending all of my time right now doing. I'm studying physics. I'm studying scattering.
That's really interesting, because so you're saying that you'd be using space and time to find the truth, which is the conscious agents outside of that.
Well, I'm using it, but in an interesting way. You're right. I'm using it, but in an interesting way. I'm not starting with space and time and then trying to figure out how conscious agents might arise. I'm saying I've let go of space and time for the moment. I got a mathematical model of conscious agents, and now I'm saying, how do I test that model? Well, I can only test in space and time, right? That's all. That when I do an experiment, I have to be able to see the result. I can only see in space and time. So I have to show how this dynamics projects back into space and time. And before I do any experiments, I just need to show that I can get special relativity, general relativity, and quantum field theory coming out of it. If I can't do that, you don't need to do any experiments. I'm wrong. There's just no experiments needed. Hoffman is wrong. If you can't get all of modern physics coming out of it. So I'm literally spending my time, I'm primarily studying the work of Arkani-Hamed and his amplitude-hedron and his more recent work on the cosmological polytope. And what I would like to show is that I can get the cosmological polytope, the amplitude-hedron that he's discovered behind space and time, that I can get them from my dynamics as the asymptotic behavior of my dynamics of conscious agents. So what Nima and many physicists are doing is they're saying space-time from the point of view of physicists, not from me as a cognitive scientist, from the point of view of physics, space-time is not fundamental. It can't be fundamental. And if you're interested, I can tell you why they're saying that, but space-time is doomed. That's not me, that's the physicists saying space-time is doomed. They're looking for a deeper structure, and that's where this amplitude-hedron, the associahedron, and this cosmological polytope are coming from. These are structures that don't know Lorentz invariance. They don't know unitarity. They don't know space and time. They don't know it. But space and time and unitarity and quantum theory arise from this deeper structure that doesn't care about any of those things. And so they've discovered these deeper structures like the cosmological polytope. And so they've done half of the work for me. All I need to do is to show how the dynamics of conscious agents can give rise to these structures that they've already found behind space and time, because they can tell you how to get space-time from those structures. So that's what I'm doing. I'm spending my time, and by the way, it's not trivial stuff, at least not for me. So I'm going to be at this for a while. I mean, it's like getting another PhD. You don't do it overnight. So I'm really studying this stuff, and I've got a couple mathematicians who are working with me. So there's hope.
I find this really interesting because I'm interested in the theory of consciousness, but I use time as a construct, and I've been doing so much research on time perception and the arrow of time and entropy, and it still doesn't explain. So I think your theory, it makes a lot of sense.
But yeah, you're right that we cannot start with time, and that's very interesting. Even attempts, I think within physics, to say, well, it's not time per se, but what some call thermal time, where they try to start with the notion of entropy instead of time, right? What Nima and his collaborators have found is a new, deeper structure, and this is, by the way, only in the last 4 or 5 years, so this is brand new stuff. But if you want to see what they're doing, just Google the cosmological polytope and Nima Arkani-Hamed and Benny Casa and Juan Maldacena. These are all collaborators. And what they found is there's this deep structure that has no time, this cosmological polytope. But when you go to one of the facets of this deep structure, on that facet, you get time emerging. You also get Lorentz structure emerging and unitarity, all on this one facet of this cosmological polytope. So that's exactly where I'm headed. And what's quite exciting to me is that I think that the asymptotic behavior of Markovian dynamics, well, we know that the long-term behavior is cyclic, right? The asymptotic behavior is either invariant or cyclic. And when you go to the cyclic behavior, the so-called asymptotic behavior, you get something called the Birkhoff polytope. And the Birkhoff polytope is basically a cousin of the structures that the physicists are finding. So that's where I have really high hope here, because the Markovian dynamics leads to the Birkhoff polytope. The Birkhoff polytope and the positive Grassmannian that they're using are cousins. So
thank you.
Okay, we have another question. Philip, did you want to ask your question?
Yeah. So my question is, so given this polytope, what would be the structure, the geometric, not necessarily physical structure, but just informational geometric structure of a conscious agent, like for example, like a topology, like a loop or a cylinder or a torus or anything?
Well, the nice thing is that the theory of conscious agents, all it assumes is that there's a measurable structure. So probabilistic measurable structure, right? When you do probabilities, you have to have a probability space, right? You have to have a set of events with an algebra of events, so-called sigma algebra and so forth. That's all I assume. That's the only structure I assume for the conscious experiences. And the only structure I assume for the choice function is that it's some Markovian kernel, some conditional probability distribution system.
Couldn't you say that sorry if I'm interrupting.
So just to answer your question briefly here, I can put other structures that I want, any other structures that I want, right? But I don't require them up front. All I have is the measurable structure up front. But I could imagine having systems that have certain kinds of topologies, networks of agents that have certain topologies and so forth. So I'm allowed to put other structures on, but I don't want to have those structures be the restriction up front, because anything I put up front is the limiting. What I'm saying, consciousness, if I said it has to be a certain topological structure, then I'm saying consciousness must always have this topological structure. I don't want to do that unless I'm forced to.
Perception action loops could create a certain topological structure, a certain kind of a loop where...
Yes.
Yeah.
Absolutely. And the nice thing is then you can start to, with the minimal assumptions that I've made, you can start to look at and classify the kinds of behaviors that could come out. Often those kinds of behaviors will depend on the kind of Markovian kernels that you have, right?
What are some examples, if you don't mind?
Well, so for example, if you have a Markovian kernel, it can have just an invariant measure. So in some sense, it's sort of boring. The behavior is that you have a certain set of states, and there's a certain probability measure on all the states. And at every step of the dynamics, that same probability of states holds all the time. So you're just sort of sampling the various states according to some fixed probability measure. That's sort of boring. But then you can have this very interesting cyclic behavior where you might have 50 states and you're cycling through them in some interesting fashion. And when you start having this kind of cyclic behavior, that's where I think you're starting to get this notion of time emerging that isn't there. So the time that we have, like in space and time, will come out of that cyclic asymptotic behavior. The step-by-step dynamics of the agents themselves has no notion of time. There's a sequence. There's, in some sense, for each agent, there's an order. This experience followed by that experience, followed by that experience. So each agent has its own total order of experiences, but there's no global notion of time. There's no general relativistic notion of covariant time or anything like that at all. There's just order relations. So that notion of sequence in the realm of conscious agents is different from the kind of cyclic behavior that you get from the asymptotics of the conscious agent dynamics, which I'm hoping will show that that's where we get the notion of time in space-time.
And how do you define then similarity between those states?
Well, between conscious agents?
Between the states in the conscious agent.
Well, so if you have just a measurable structure, so notice, by the way, I haven't put any metric in the definition of a conscious agent, right? There's no metric. So a priori, there's no notion of similarity, which is a sort of a metric, a closeness kind of notion. So there's no topology, so there's no neighborhood notion, and there's no metric, so there's no nearness notion. Now I can, of course, add interesting structures. So for example, if I have a measurable space and there's some probability measure on that space, it turns out you can induce a metric from the probability measure. You take the measure, so if you have two different sets, A and B, the distance between A and B, so these are just events, right? Event A and event B. And a priori, they're just events. There's no notion of topology, of nearness. There's no notion of distance. They're just events. But if I have a probability measure on the whole space, I can take what's called the probability of the symmetric difference, asymmetric difference B. So if you take the event asymmetric difference B and take the probability measure of that event, it turns out if you look at that symmetric difference and the measure of the symmetric difference, you can prove that that's a metric. So if I have a probability measure like this invariant measure that I mentioned that comes from the long-term behavior of the dynamics, and I have a measurable structure, then there is a canonical way to put a metric on the space of events. The metric will depend on the probabilistic behavior of the kernel, and because that tells you what the long-term invariant behavior of this probability measure will be. So you'll get a different metric, a different notion of closeness for different kernels. So that's the kind of thing that I'm looking for here is, right, I want to have the minimal assumptions up front and then let the machinery, the dynamics give rise to any of the interesting behavior. I want to have the dynamics give rise to space-time. I don't want to just put it in by hand. I want the dynamics to give me the metrics and so forth. I want to put it in by hand. That's the fun of this.
So we have another question. I'm gonna unmute Harley. If you want to ask your question, Harley.
Yeah, so, I mean, just hearing you talk about your theory now and reading, you know, your essay on the interface theory of perception, it seems to be refuting this naive realist view of the world that people, you know, directly perceive reality. But I guess I'm kind of wondering, based on the argument that consciousness reconstructs reality, it seems to, you know, move towards a more solipsistic view of the world, but I'm not sure if you would consider yourself either solipsistic or a materialist, where there is some outside material reality that just can't entirely be known. And I guess my question is, how can this sort of external material reality ever be known if we are always reconstructing reality based on our, you know, skewed perception? And
great question. So I'll talk first just a little bit about the naive realism and then about solipsism. So the work that I've done on evolutionary game theory with my collaborators, my graduate students and colleagues, what we've shown is that naive realism is incompatible with evolutionary theory.
right.
If you take evolution by natural selection seriously, the probability that any aspect of the structure of our perceptions, any aspect of it, is related to the structure of objective reality, probability is 0. That's just a theorem of evolution by natural selection. So you can't say, I think that we see reality as it is, that when I see space and time, I'm seeing the truth or aspects of the truth, and also say that I believe in evolution by natural selection. The two are incompatible. You have to choose. If you want to buy evolution by natural selection, you have to let go of naive realism. That's what the theorem says. And if someone, now, by the way, here's a way that someone can try to take me down on that, and I would welcome someone trying to do it. When I proved that theorem with, well, my colleague Chetan Prakash proved it. When I worked with him on this, the measure that we're using is a uniform measure on the set of all payoff functions. So we start with a finite number of functions, and we let the number of functions, the complexity of the functions grow. But we can always count them. And so we look at the limit as the number of payoff values, the number of states of the world goes to infinity. We show that the probability that a payoff function is a homomorphism of any structure in the world goes to 0. But that's for a uniform measure, a counting measure on the payoff function. So if someone could come along and give a principled reason why there's a different measure, then they could try to disprove our theorem. So I'm putting out how you could try to disprove the theorem, right? Show that the counting measure is wrong and come up with a different counting measure. So that's the first thing about naive realism. By the way, I would be really interested if someone did that. But you'd have to change evolutionary theory, because evolutionary theory gives no principled reason for choosing a measure other than counting measure. The idea that it's random mutation and random, the randomness of the process. And you can say, well, there is some evidence that mutations are not completely random, that's in some sense they're sort of, you have more mutations where you need them. So if you could try to turn that kind of idea into an argument against the uniform prior that we're using, that would be interesting. So that's interesting work. But right now the state of play is naive realism is incompatible with evolution by natural selection. Now on solipsism, there's two kinds of solipsism. There's epistemic and ontic, or metaphysical. Epistemic solipsism is the doctrine that all I can know is, in some sense, my perceptions. I can't know anything beyond my perceptions. I can't know what's in your head. I can't know what's outside the realm of my perceptions. That's, epistemic solipsism. And that's different from metaphysical solipsism, which says the only thing that exists is me and my perceptions. You can see those are very different things, right?
Right.
One is saying I can't know beyond my own perceptions. The other is saying there is nothing beyond me and my perceptions. And so I'm clearly not a metaphysical solipsist. I'm proposing that there's this whole vast social network of conscious agents, and I'm just one of them. In fact, I'm just a tiny part of this whole thing. So it's definitely not a metaphysical solipsist point of view at all. I'm being realist about consciousness and realist about all these conscious agents. So I'm saying they really are out there, even though I'm not aware of them. I'm not directly aware of them. They're out there. So I'm not. And in terms of epistemological solipsism, there I would say, strictly speaking, I can't know. I can get degrees of belief, but yeah, if you press on me and say, can you know for sure? Can't know for sure. So in that sense, yeah, I guess I'm a epistemological solipsist, but that's, I'm saying I have to make probabilities. I can't know for sure. So
right.
That's sort of a benign form of epistemological solipsism.
So, I mean, just a follow-up question, because you mentioned like your game theory simulations and how, that shows that naive realism is false based on evolution. Could you sort of, maybe this might help the audience as well, just get a better understanding, but could you explain that simulation and how it works, I guess, to someone not too familiar with game theory and game theory simulations?
Right. Well, there's a couple things I can say about that. One is that there's the key notion in evolutionary game theory is the notion of a fitness payoff, right? And that's what really is the issue here. So think about evolution as like a video game. And when you're in a video game, you if you want to survive and get to the next level, you have to focus and shoot things or whatever you have to do to get points. Get the points as fast as you can. You can't dally around. So you grab points as fast as you can. If you get enough in a short enough number of times, short enough amount of time, you can go to the next level of the game, and then it's harder. Well, in evolution, it's the same kind of thing. There are these fitness payoffs, which are like the points in the game. And if you get enough of them, you don't go to the next level, but your genes do, right? You have offspring, and they go to the next level of the game. Now, these fitness payoffs are, they are functions of the world, right? So whatever objective reality is, fitness payoffs do depend on objective reality. But they also depend on the organism and its state and its action. So So they're functions of the world, but they're really complicated functions. They're these nasty functions. And so they start with the world, and then they give you points. So maybe there's a total of 100 points that you can get. And so an action might give you 0 points to 100 points, and that's your fitness payoff, or 0 points to 1,000 points.
Right.
And so you have this payoff from 0 to 1,000 points. It depends on the state of the world, but all you know is how many points you got in evolution. So the real question that comes out of our simulations, the real insight was, in evolution, your senses will be tuned to tell you what points you will get if you take certain actions. If I take this action, I will get these points. If I'm in a video game, if I shoot at that kind of icon on the screen, I will get these points. If I shoot over there, it'll blow up and it'll kill me, right? So I know, I don't know what's really going on, by the way, in a video game. The real thing that's going on is some supercomputer with diodes and resistors and voltages. That's what I'm really interacting with in that metaphor. All I know is I see this alien over here, and I better not shoot him because he'll blow up and kill me. And if I shoot over here, I'll get points. That's all I know. I don't know the truth. I just know what will give me points. And that's what evolution has done. And the reason is that these fitness payoff functions, and this is the proof that I was mentioning to you, the fitness payoff functions, you can show, erase information about the structure of the world. Suppose the world had a total order, like it had something that has little, a medium, or a lot, like oxygen, a little bit of oxygen, medium amount, or a lot. You can prove, and this is, and by the way, if anyone's interested, I can send you a link to the paper. It just got published a few weeks ago. We prove, and you can look at the math, that the fitness payoffs, it's a combinatorics argument. We can literally count all the fitness payoffs. If there are n states in the world and m fitness payoff values, then you can compute the total number of functions, right? There's m values for the first, m for the second state of the world, m values for the third state of the world. So that's m to the n possible payoff functions, right? So there's m to the n possible payoff functions. And then you can literally ask, how many of those payoff functions would preserve, say, a total order, or preserve a symmetric group on the world states, or a permutation group, or a measurable structure? Those are the 4 that we've actually looked at. And in each case, you do the combinatorics. You put the number of homomorphic payoff functions in the numerator, the total number of payoff functions in the denominator, you divide, and take the limit as the number of states in the world, and the number of states of the payoffs goes to infinity. And you find out what's the probability that a randomly chosen payoff function would have some information about the structure of the world. The answer in every case, precisely 0. Precisely 0. No equivocation, it's exactly 0. And I believe it'll be the case for every structure that we look at, because what does it mean to be a homomorphism? A function has to satisfy certain equations. That's hard to do. Most functions, randomly chosen functions, will not satisfy the equation that you need to satisfy to be a homomorphism for whatever the structure is. So the simulations, by the way, I did simulations first with my graduate students just because I didn't know what the answer was going to be. I didn't have the math. I just wanted to see, will creatures that see the truth in my little games, will they survive or not? Or will they be, more fit? And I was finding that they were going extinct. They couldn't outcompete these creatures that saw none of the truth. So then I had the temerity to think there's a theorem here. And that's why I went and we discovered this deep fact about fitness payoffs, that they erase. So this is the bottom line. Fitness payoff functions in evolution erase all information about the structure of the world. And we're only tuned to the fitness payoffs. Therefore, we're not tuned to the structure of the world. It's that simple. It's stunningly simple. So I hope that helps.
So basically, sorry, I don't want to take up too much time, but having greater payoffs in terms of fitness and survival would equate to, less accurate perceptions of reality. So basically, if the total points you have in survival is greater, that would mean that the payoff would be reality. I don't know if that's the right way to look at it.
Well, think about it this way. Suppose you have two people that are going to play a video game, like Grand Theft Auto.
Mm-hmm.
One gets to use the nice Grand Theft Auto interface, and the other person, you say, look, here is an electrode, and you have to toggle voltages in the supercomputer, and that's how you're going to play the game. Ultimately, the guy with the Grand Theft Auto interface, he's toggling voltages in the computer as well, right? He's toggling the bits. But you have to do it, you have to know the reality directly. You have to toggle all the bits. Who's going to win the game? Well, the guy, if the game is to play, win Grand Theft Auto, I would bet on the guy who actually has the interface every time. The guy that's toggling bits is not going to win. And that's sort of, a metaphor for why seeing the truth will make you extinct. You don't want to know the truth. You just want to play the game. And that's what evolution has done. It's given space and time, and physical objects are merely this VR headset that helps us play the game of life from the point of view of evolution. Now, this raises another question, which is, am I being inconsistent? I'm using evolutionary theory to prove this, but am I saying that therefore there's an evolutionary theory of consciousness, that the evolution is the right dynamics for consciousness itself? Well, what's going on here? And so it's very important for me to say the strategy, the argumentative strategy that I'm using here. And this is what we do all the time in science. What we have to do, first of all, is we have to take our best current theories, right? So right now, there's the three major theories. There's quantum field theory, general relativity, and evolution by natural selection. These are like our big three pillars of modern science. We have to push them to their limits and see where they break. And so that's what I'm doing with evolutionary theory. I use it not because I think it's the final truth. I don't think any of our scientific theories are the final truth. That's just, but on the other hand, I would be stupid not to both respect and study our current scientific theories. I would be stupid not to do that. So I have to respect, and frankly, I admire them. They're incredible, beautiful theories, brilliant, and they're deeply wrong. And so the point is to take our theories, figure out where they're wrong. It's not easy to do because they're not stupidly wrong. They're wrong in very, very deep and interesting ways. So I'm using evolutionary theory to point out that evolutionary theory is saying space-time is not fundamental. That's what I'm using it to show. It's saying you need to actually let go of space-time and physical objects. They cannot be fundamental if you take evolutionary theory to be true. So now, having done that, what evolutionary theory does not do, it does not tell me what new theory to go for. It says you can't use space-time, which is the framework in which evolutionary theory has been developed. It's saying that whole framework is inadequate, but it cannot tell you what you need to do next. So that's where the creativity comes in. As a scientist, you go, okay, it's not space-time. Evolution won't tell me what's the new theory. So this is my chance to be creative. What am I going to do? I get to propose a new theory. I can do whatever I want right now, but once I do it, then evolution will be a test. Whatever my deeper theory is, I need to show how space-time arises. And when I show how space-time arises, then I better get evolutionary theory in that special case. So evolutionary theory can tell me if my deeper theory is wrong, but it can't tell me what the deeper theory should be. It's just there to tell me if I'm wrong. So that's my argumentative strategy. I use evolutionary theory to destroy space-time. Then I make a creative leap and say, here's this network of conscious agents, this vast network of conscious agents. That's what I'm proposed beyond space-time. And then I have to go back and reconstruct space-time from it and get evolution by natural selection and quantum field theory coming out.
Fascinating. Thank you so much.
And then I'll have lunch.
So we have another question. It's from Francis. So I'm gonna unmute you here, Francis.
Well, yeah. Basically, in listening to you at near the start, I was wondering this underneath fundamental structure, Do you equate that to current space-time through, they've always posited that there's more than the 3 or 4 physical dimensions in time. And time itself, then, do you view that as sort of a shorthand then for basically, and you may have already answered this as far as how to handle change. In other words, we create time in order to handle change that is actually occurring all around us. A happened after B. Hence, whatever increment that was is time, and we use this as a big catch-all in a lot of math to physically handle change. I didn't know if you wanted to comment about those 2 areas.
Well, so what the physicists are doing on this, when Nima and his collaborators are going beyond space-time, they're doing something far more profound than what you see in string theory, where you say, well, there's like 6 extra dimensions curled up, right? You can see the 4 normal dimensions, and there's 6 others that are curled up. That's nowhere near as ambitious as what they're doing. They're talking about a structure that's utterly new. It's not some curled up dimension inside space-time. It's a fundamentally different structure. So the amplituhedron, the associahedron, these are not like little curled up dimensions within our space-time.
Yep.
We're throwing away space-time altogether. There's this new structure that's entirely on its own, and certain special property. So this structure doesn't care about space-time. It doesn't care about quantum theory. It doesn't care about any of that stuff. It just so happens that on certain facets of this structure, when you go to certain faces of this, it's like this billion-dimensional diamond. And when you go to one of the facets, you get space-time out.
So,
and you get unitarity and so forth.
So does the space-time structure of the universe, is it live within it? So you say you go to a facet, is
right.
So it's totally consumed. It's more along the lines of maybe David Bohm. You have an implicate and explicate
right.
order.
Yeah, absolutely. No, Bohm was absolutely brilliant, of course. But on his implicate order, beyond his pilot wave, when he was doing his implicate order thing, I think that he was reaching for something beyond his pilot wave theory, right? I mean, and he wasn't able to mathematically get at that. And I think, so yeah, there's a sense in which Bohm's deeper desire for an implicate order is what physicists are now actually finding in this, cosmological polytope, the amplituhedron, and so forth. They're actually finding now, with mathematical precision, these structures that are the implicate order.
Yep.
Right.
Okay. Cool. Yeah. Cool. I understand it.
Yeah, it's pretty cool. And so then my goal is to show. See, the physicists here's where the physicists, I think, are stymied. So they've found this structure, the amplituhedron or the cosmological polytope, but it's just a structure. The question is, why? Why? At least in space and time, we can talk about things are happening, things are moving, but here's just this diamond, this abstract diamond, this polytope, this cosmological polytope. Who ordered that? And why? What's going on? There's no notion of a process, right? It's just this static structure. So what I'm hoping to do is to show that there is behind their polytopes, the amplituhedron, cosmological polytope, there is this deeper network of conscious agents. There's a process. There are these interacting conscious agents, but when you only look at the asymptotic behavior of the conscious agents, that's where this structure, this polytope, comes from, the cosmological polytope. So that's who ordered it. It's in some sense the reason why physics has never seen consciousness is because at best physics can only look at the asymptotic behavior of the network of conscious agents. They can't see the individual consciousnesses interacting.
But then don't you come up with the same question of why?
Yeah.
I mean,
well, ultimately, yes. I mean, the question that you could ask me is, so why should conscious experience be fundamental? And why should choice be fundamental? And at some point I'll have to say, got me, right?
Yeah.
and that's what every scientific theory will ultimately say is, got me. Those are my assumptions. But in the case of the polytope, it does seem like I'll put it this way. Even though I would say got me, nevertheless, there's some sense in which I would say, But look, I can't deny that I have conscious experiences. So it seems like a natural assumption, whereas there's just this polytope sitting there. Why? I mean, that really does ask for a why question, a deep why question. And I would like a process answer. And so that's sort of what I'm getting after here.
Yeah. No, very cool. Very cool work. It's very cool discussion. Thank you.
It's a lot of fun.
It is.
So just being mindful of the time, it is 5. Are we okay to continue with the questions we still have, or are we?
There are a couple more questions. That's fine with me.
Okay, awesome. Philip?
Yeah. This polytope has a certain geometric structure, right?
Right.
But wouldn't a network of conscious agents also have a certain geometric structure then? So you just kind of shift it from having this one geometric structure to having another geometric structure behind it. And then could you say there's a polytope for those conscious network of conscious agents? So another polytope, right? And then,
Right. Right. So in other words, what's so different about what I'm doing with these polytopes that the physicists are finding? And I think what's different is that I'm proposing to say what really is fundamental for me are conscious experiences and choices based on conscious experiences. And the math I write down is really in service of those ideas, right? And the math I wrote down was primarily, the guide for me in writing down the math was to be as minimally constraining as possible. The reason I said, let me just say that the set of conscious experiences of an agent is a measurable structure, is that was as far as I could tell, the most minimal assumption I could make. There's no smaller assumption. If I want to be able to talk about the probability of having an experience, I have to have a measurable structure. So if I want to be able to do science, and as a scientist, I do want to be able to do science. So the minimal structure you need to do science is a measurable structure. If you don't have a measurable structure, you can't talk about probabilities, you can't have empirical tests, it's game over. So that was my motivation. The mathematics is motivated by the idea of conscious experiences being fundamental and doing the minimal assertion of structure that would still let me do science. So whereas the feeling of the polytopes that you get from the physics, and by the way, I'm not putting down these polytopes. These people that are doing this are just geniuses, and this is amazingly good work. But what they're doing is they're stepping back and they're just saying, oh, if we had this mathematical structure, then we could give rise to space-time. But that then begs the question, but why is reality such that this is the deep mathematical structure? It begs that question. I'm sort of proposing an answer up front. I'm saying, here's the reason for this measurable structure. Consciousness is fundamental. That's my proposal. Consciousness is fundamental.
Well, let me
disagree with me, and that's perfectly fine.
A follow-up question then, based on that. So these conscious agents would be embedded within one of the facets of the polytope, correct?
No, quite the opposite. The
It's
conscious
the
agents
polytope.
they transcend the polytope. The polytope is only a distillation of the long-term behavior of the entire network. So I have this vast network of conscious agents. And only if you ignore most of the dynamics of the conscious agents and only look at its long-term behavior, do you get this polytope. And then only if you go to one facet of the polytope do you get space and time and what we thought was the ultimate reality, space and time in physical objects. So I'm saying what we thought was the ultimate reality is well removed from the ultimate reality.
But then the polytope, that's supposed to encompass everything, right? It's supposed to emerge into everything.
It's everything in space-time. Everything in space-time emerges from the polytope. But I'm saying that conscious agents themselves are even deeper than these polytopes.
So well, then let me go further. So evolution by natural selection depends on a certain arena where these competitions and mutations and sexual selection can take place, correct? So doesn't that depend then on an externally real material reality, right?
Well, that's the way we typically think of evolution by natural selection. We reify objects in space and time, and we've assumed that evolution by natural selection is about real objects with real cause and effect in space and time.
Well, let's say it's not even objects. Let's
Like
say it's
like DNA and in
configurations.
RNA.
Yeah.
So I missed your question.
So let's ignore that it's even objects. Let's just pretend it's all just configurations within. I want to say space-time, but yeah, space-time configurations within space-time, which, for example, creates my morphology, my genotype, phenotype, whatever. So all of this kind of stemmed from non-cognitive chemical structures in the beginning, the soup or whatever of life, and then only after that did cognitive systems emerge, like maybe basic bacteria that could swim towards light. But before that, it was just this configurations of space-time, and only after that did a conscious agent emerge. So then how do you put these together then? That conscious agents came before, but then they also depend on space-time.
Right, so I'm saying that the whole Big Bang story is wrong. Right, the Big Bang story is only a story about space-time. So the story is that 13.8 billion years ago, space-time somehow banged into existence, but in that story there was no life and a fortiori no consciousness for hundreds of millions, billions of years. Life came along later, and then after that, somehow the first flickers of consciousness came on. That whole story is wrong from the get-go on this point of view. And by the way, that whole story is wrong from the get-go in the polytope story that the physicists are saying. Space-time is not fundamental. There is a deeper framework, and space-time is only one facet of this deeper cosmological framework. The very notion of time itself is just one facet on this deeper thing. So the physicists themselves are coming up with a deeper structure in which the Big Bang story is only a story on one facet of this deeper polytope. But then I'm saying the whole polytope that they've discovered is only a small aspect of this deeper dynamics of conscious agents, right? So all of the polytope, including this one facet that gives rise to the Big Bang, that whole polytope is only a shorthand description of the long-term behavior of this vast network of conscious agents. So conscious agents, in this point of view, are fundamental. And in some sense, evolution by natural selection then, here's how to think about evolution by natural selection. I mean, a question that you would certainly want to ask about my framework is, what are these agents up to? Right? They're doing something. What is it? What are these agents up to? And the answer is I don't know, and I only have one idea that is deep enough to at least be taken seriously. I'm not saying it's right, but I don't have any. I've never seen another idea that's deep enough to even be taken seriously for what these agents are up to. And it's the following idea. It comes from Gffdel's incompleteness theorem. And Gffdel showed that in some sense, no matter how much math you do, there's always going to be endless more mathematics that's not entailed by what you've done. And there's anything that you do, there's more mathematics to discover. There's endless, so I'll put it this way, there's endless discovery of mathematical structure, right? If, strictly speaking, what he said was, if you give me a system of axioms, there are things, I can show you there are things that are true, but can't be proved from your axioms. If you add the new truths to your axioms, then there'll be absolutely new things that are true, but can't be proved by your axioms. What that means is there's endless exploration of mathematical structure, brand new novel mathematical structure. Now, in my framework, in which all that exists is consciousness, conscious experiences and choices, then mathematical structure is only about one thing. It's about conscious experiences and choices. That's what it's about. If it's about anything, it's about conscious experiences and choices. And so what Gffdel is telling us is that there's what I call Gffdel's candy store, an infinite variety of exploration of conscious experiences. And in principle, it's unending. That's what Gffdel's incompleteness theorem is telling us. There's, in principle, no end to the exploration of structure, and that means to the exploration of possible conscious experiences. So what's evolution about? It's the kid in the candy store view. There's endless variety of experiences to explore. Go out there and do it. And so it's in some sense, you can think of it as a search, but it's an endless search. You can never come to the end of it in principle. And the trivial image of that search is what we call evolution by natural selection and gene mutation and so forth. So ultimately, what I want to be able to show is that what we call, evolution and genetics and parenting and the whole bit, all of that is really just a really dumbed down interface representation of this very rich exploration of Gffdel's candy store.
So this is kind of like Tegmark's mathematical universe theory, where every mathematical formulation of a universe is real to some extent. But doesn't this all depend on causality fundamentally? Communication depends on causality, perception, experience, choice. It all depends on causality and communication. So then isn't causality somehow more fundamental than these conscious agents that are working within the causality?
Great question. First on Tegmark. Tegmark wants to take mathematics as fundamental. And I'm taking conscious experience as fundamental. That's a huge difference. The relationship I see between conscious experience and mathematics is like the relationship between a living organism and its bones. You need, if you're a vertebrate, you need the bones. But there's much more to us than just our bones. And so that's so I disagree with Tegmark. I think that, I love mathematics and it's beautiful and it's part of the fundamental reality, but it's not the entire fundamental reality. It's the bones in some sense. And consciousness is more than just the bones, but it does have structure. So conscious experiences are structured. I study psychophysics and we find structure in experiences, but there's more than just the structure. So I disagree with Tegmark on that. The multiverse idea that Tegmark and others have is also very different from what I'm talking about. So their multiverse is quite interesting. It's when you look at inflation in the standard model of physics, you look at inflation, it turns out the equations of quantum field theory allow for lots of scalar particles, lots of different kinds of vacua, false vacua. And string theory also allows for all these false vacuums. And there are 10 to the 1,000 of them or more. There's like all these different vacuums, and each vacuum has a different kind of structure. In some vacuums, the universe will be, in fact, in most of them, it could not hold any life. It's either expanding too fast or it's crunched down to the Planck scale. There's very, very few of these, this whole landscape of possible universes that are mathematically possible in which any structure could really survive. And so this is the source, Steven Weinberg and others have proposed that there's this anthropic principle. The reason why we live in a universe with a certain cosmological constant and so forth is because there's this whole landscape that were proposed that are possible from quantum field theory. Most of them are fatal to life. Most of them couldn't, and so that's why we live. But the key thing that's different about that from what I'm saying is these are all physical universes with the same fundamental laws of physics. String theory is unique, right? It's a unique theory. All these universes are different solutions for the vacuum of the string theory. So in some sense, there's the grand unification that string theory has here. All of these different universes with different vacuums and different particles and so forth, in none of them do apples fall up. They all have the same laws of physics, but some of them have more structure than others. But they're all physical universes with the laws of physics. And so what I'm saying is that all of that is just what the physicists are saying. All of that is just one facet of this cosmological polytope, and that polytope is just the asymptotic behavior of this network of conscious agents.
Right.
So that's the difference between the two.
But then you could also mathematically model, say, any conscious experience that, or any conscious system, if you wanted to. Like, I don't know what the equations would be at all, but say, for example, you're giving a mathematical structure for conscious agents. You're giving it a minimal structure, but it's still a mathematical structure. So within this multiverse, mathematical multiverse, you could have almost like Boltzmann universes where the small universe is almost in the structure of a conscious agent, right? And then this small universe would then have these properties that you're saying at its most basic level as a physical system. So I see that from my perspective, the mathematical multiverse includes these conscious agents because the conscious agents are mathematical structures.
Well, so the way that the physicists think about the multiverse is that there's string theory. String theory is unique. It's you can't play with string theory, but it has countless solutions. The laws of physics are the same, but the solutions in terms of the particles and their couplings and their properties are different. And so we have this endless set of string theoretic universes. Now, what Nima and these guys are doing is they're saying that there's this polytope that's much, much deeper than string theory itself. So this is not me now. This is just, I'm talking about physics, right? So string theory is a theory in the bulk, as they put it, and at least in what they call the ADS-CFT correspondence. You have a string theory in the bulk, in the volume in the middle, is identical to, is equivalent to a standard quantum field theory on the boundary. So string theory itself is wonderful, but it's sort of stuck in space-time. And what Nima and these guys are going for is something deeper than Lorentz invariance, deeper than quantum theory. See, quantum theory itself arises out of the polytope. It's not in the polytope. The polytope is more fundamental than quantum theory. So that's why this whole string landscape does not include the polytope, and therefore doesn't include this conscious agent stuff. The whole string landscape is based on quantum theory. Quantum theory itself is merely emergent from the polytope, this cosmological polytope. So it's hard to wrap the head around, because this is brand new stuff. It's only 5 years old, and we've been programmed by natural selection to believe in object permanence, right? When we were 3 or 4 months old, we believed that the doll, when mom put it behind the pillow, still was there. And that's, from my point of view, that's why we're all physicalists. And that's why scientists are physicalists. We believe that our dolls were behind pillows that existed, and because we're programmed to believe in object permanence. And it's hard for us to let go of it. But physics is now realizing object permanence is wrong, space-time permanence is wrong. Space-time itself is not the background, it's not the fundamental reality. And with it goes string theory and the whole string landscape. So all those universes, all those string universes, the 10 to the 1000th of them, they all are not as fundamental as this cosmological polytope. And this is not my point of view. I'm just telling you what the physicists are doing.
Yeah, and then, but doesn't the polytope? Sorry if I know I'm going on too long, but it's the same question in my head. Doesn't the polytope also include these mathematical configurations of consciousness? Like any configuration of consciousness could be included within the polytope.
No, it's the polytope to the network of conscious agents is very much like, suppose that you're in a helicopter, a mile above the traffic on the freeway, and you're looking down at the freeway, and from your point of view in the helicopter, you could model all the cars on the freeway just using the equations of fluid dynamics, right? It looks like fluid flow of particles in the arteries of the freeway. But that's because you're only seeing from a helicopter's point of view from far away, asymptotically. You don't see the individual person in there who is, now they're looking to the right, now they're looking to the left, now they're pushing on the gas, now they're pushing on the brake. In other words, there are conscious drivers inside each car. And you can ignore all of them. When you do your fluid dynamics modeling, you're ignoring all the individual judgments and movements of the drivers. You're just doing a fluid flow because you're looking at only the asymptotic behavior. And so that's what physics is doing. The polytope is only the asymptotic behavior. It's the helicopter view of the conscious agent dynamics. It's missing all the real life of the conscious agent dynamics. Just like the guy in the helicopter, he can model it as fluid flow. That's what the traffic is. It's all fluid flow down on the freeway. But he's missing the life of all the individuals driving the cars and sweating and trying to be careful and not run into each other. He's missing all of the reality and just sees fluid flow. Same thing with this polytope. The physicists are only getting the helicopter abstract view. They're not seeing all the conscious agents and all their interactions. They're just seeing the big Gaussian blurred view of it, if you will.
But if you zoom into a facet,
then you get, of the polytope, then you just get, for example, our little space-time. So you're actually zooming even further away from the reality of conscious agents. So the polytope includes a facet which has our space-time and presumably, not just our format of space-time, but the whole string landscape of them, right, is there. But that's just a special case of the polytope, and the polytope is just a special case of the dynamics of conscious agents. But what the weird thing is, we ourselves are conscious agents. We feel like we're in space and time, but when you put on a headset in a VR game, you feel like you're immersed in the VR game, but you're not, right? So if you ever played VR and you have a very immersive experience, you get this really compelling feeling that you're embedded in that virtual universe that you're in, but you're not. It's just a feeling. And so what I'm saying is, we feel like we're little tiny entities on this vast pre-existing stage of space and time. Space-time's been around for 13.8 billion years, and we're little bit players that have come onto the stage at the last few seconds of the play. And I'm saying that's the way it feels, what we've been taught to believe, and I'm saying it's utterly false. We're not little bit players, we're the authors of space-time. We create space-time. We're not little bit players on a pre-existing stage of space-time. It's a complete reorientation of everything that we've believed.
thank you.
Okay, we have a question over here. You are unmuted.
Okay, so one question I had was, where does this cosmological polytope come from? Because the issue is that if our existence is based on one aspect of the cosmological polytope, and causality is a huge aspect of our lives, we always look at something based on, where did this come from? What is the source of this? So does that mean that the cosmological polytope has always been there? It didn't come from anything. It's just been existing. Hasn't been created.
Right. So I think of course, I won't speak for these people. I'll tell you my thoughts about what they might be thinking, but we could ask them themselves. But my understanding of it right now is they have just been looking for a structure that doesn't have quantum theory in it at all, that doesn't have Lorentz invariance in it at all, and they're trying to find a structure that would give rise to quantum theory and Lorentz invariance. And they found one. They're just really happy to find one right now, and they're still trying to. So they're still, it's so new that they're just trying to find what this polytope looks like. They still have a lot that they don't understand about. They're trying to understand its structure. I'm sure that they're wondering, what the heck, why, who ordered this? But I doubt that they have any answers right now. This is probably, they would probably go, your guess is as good as mine. So that's where I'm proposing that here's where it comes from. It's just the asymptotic description of consciousness in all of its glory, right? But consciousness in all of its glory is too complicated, so we have this asymptotic description. But the notion of causality is important, and the last questioner also brought up that, and I didn't get to it. What this point of view is saying is that, strictly speaking, there is no causality in space and time in the following sense. If I hit the cue ball and it knocks the 8-ball into the corner pocket, there is a story I can tell in which the cue ball caused the 8-ball to go into the corner pocket. But strictly speaking, if the point of view that I'm saying is correct, there's no more causality in that than if I'm playing Grand Theft Auto in a virtual reality and I'm holding onto the steering wheel and I turn the steering wheel to the left and my car starts to turn left. If I say, well, the steering wheel caused my car to turn left, well, that's a harmless fiction. If you're playing the game, it's perfectly fine to say my steering wheel caused the car to turn left. But strictly speaking, if it's a VR game, there is no steering wheel. I see a steering wheel when I look and create it. When I look away, there is no steering wheel. The steering wheel has no causal powers. It's just a symbol that guides my behaviors, but the steering wheel literally has no causal powers. So in space and time, I would say, so I'm not going to put this on any physicist, I'll just say it for myself. All of the icons that we see, the moon, physical objects, these are merely icons in our virtual reality. They have no causal powers whatsoever. However, like a good video game, there is a good fiction of causality. When I turn my Grand Theft Auto wheel to the left, my car does seem to go left in the game. So I have a good fiction of causality. Same thing in neuroscience. When I take an electrode and I stimulate a neuron, I might get a twitch in a muscle or something, if it's in motor cortex. There's the fiction of causality, but strictly speaking, neurons are like the steering wheel in Grand Theft Auto. They only exist when you see them. So for everyday neuroscience, it's perfectly fine to talk about neurons, and I do this myself. I'll talk about area V4 causes color perception. If you delete area V4 by a stroke, you will lose, color perception in the right visual world if it's in the left hemisphere. So I talk about neurons and their causal effects all the time, but it's strictly speaking just a useful fiction. And when we get to the hard problem of consciousness, that's when the fiction is no longer harmless. It's a useful fiction. If you're playing Grand Theft Auto and you believe the steering wheel really causes things to happen, that's perfectly fine. You can play the game. But if you're a software engineer and you're trying to fix the game, you're trying to find a bug and fix the game, you can no longer believe in the fiction. That will get in the way of fixing the program. And that's what we're doing when we're dealing with the hard problem of consciousness. We're now like the software engineer who has to look under the hood of the game and figure out how it's working. In which case you have to know that the notion of causality in the game was just a fiction. So cause and effect in space and time is a useful fiction. It turns out it's not useful when we're going after the hard problem of consciousness, because that has been what's caused us not to be able to solve the hard problem of consciousness. We believe that objects in space and time have causal powers, and they don't. And if we're wrong about that, then any theory that we come up with, which starts with a physical object and shows how it could cause our conscious experiences, cannot ever work. It just cannot. So all of them can't work because no physical objects have causal powers. That's one of the stunning implications of this approach. And in fact, it's the implication that first made me go after this theory, because I was realizing that the problem might be that physical objects causing consciousness is just false. And so that sort of led me on this whole rabbit hole. And it's quite a deep rabbit hole where you really understand how it could be that causality in space and time is false, even though it looks true. And in everyday life, it's perfectly harmless to think that neural activity causes my behavior and causes my experience. It's perfectly harmless.
That's extremely difficult because we're using our brain to measure consciousness. So it's like we are within that reality. So how do we get out of that reality to measure it from the outside? Because we are in it. And how accurate would we be in measuring it? That's also another thing. Like, it's just a very difficult endeavor.
It's sort of pulling ourselves up by our bootstraps. So I agree. It's not easy. But I would say that I don't have a brain unless you look. and you don't have a brain, right? It's like in virtual reality. If I'm playing a game of tennis with you, virtual reality tennis, we put on a headset and bodysuit, you and I are across, and I have the yellow tennis ball, and I hit the yellow tennis ball to you, and you hit it back to me. And I could say, well, there is the tennis ball. After all, you see it. And if I close my eyes and turn my headset away and drop the ball, you can say, I still see the tennis ball. And I can say, if I look over there, yeah, there it is, just where I predicted it to be. And we can do all those kinds of things. And yet we know there is no tennis ball. The tennis ball is just something you make up when certain photons are sprayed in your headset. But there is no real tennis ball. I'm saying that the same thing is true about every physical object that we see. We create them on the fly, and we garbage collect them when we look away. The same is true of brains and neurons. So strictly speaking, none of us have brains and neurons. If someone looked inside your skull, they would see brains and neurons because that's the symbol that they're creating. Now, for everyday neuroscience, it's fine to use our brains and neurons as the language for our theories. That's perfectly fine. I do it myself. But strictly speaking, it's false.
Thank you.
It's wild. But so you're right. It's hard. How do you do this when everything that you thought was true is false? It can be done, but it takes younger brains like yours to do it.
It's also hard because we operate on causality. Like everything that happens in our lives we always like attribute it to causality. So how do we even get out of that? That's the difficult part.
That's right. By the way, if you look at books on causality, there's I think the Oxford Handbook on Causality. There are philosophers who study causality. It's very, very deep, right? There's no agreed notion even in philosophy of what causality is. Is it counterfactual conditions? Is it just laws of nature? Is there some basic impetus that's what do we mean by causality? All we have are sequences of events that we interpret in certain ways. So is it something that we just create? Like one interpretation of Hume is that there is no such thing as causality. It's just a habit of our mind that we think of things in terms of causality, but we're completely wrong. In my case, you might ask, well, in the theory of this network conscious agents, what is the notion of causality in my theory? And the only similar notion is that the conscious experiences of an agent influence its choices. So I have this notion of choice, sort of a constrained notion of free will. It's not a completely free will. It's a constrained notion of choice, but the choices are somehow influenced by the conscious experiences. And for me, it's a primitive of the theory, right? That's a primitive. And I think if you looked in a lot of physical theories, the notion of cause is either dismissed or it's taken as a primitive. And that's what we have to sort of do. This is a case again where explanation stops, right? In scientific theories, explanation always has to stop somewhere at your assumptions.
Thank you.
I find that frustrating, by the way. I don't like it. I would like to explain everything, but I can't.
That's true. We always love to explain everything.
We've got another question, if that's okay. Stop us at any time if you need to leave.
Maybe one more question, then we probably should go. Yeah.
Okay. All right. So the next question is from Ludwig. So I'm going to add you. Yep. If you'd like to ask your question. We might move on, or I can read this question aloud.
Okay.
Wouldn't that imply that we're getting a higher level of abstraction in order to interact with reality? Just like high-level programming languages are not operating directly on binary code. However, the higher level of abstraction still allows us to manipulate at a more complicated level the same inner workings of the computer.
Right. I think that's a good metaphor, that what we're seeing in space and time, we thought that we were seeing reality as it is. This is just a high-level user interface, and there's probably lots of layers of virtual machines, right? Between when you use the interface on your computer, there are many layers of virtual machines between what you see on your desktop and before you actually get to the machine, the ones and zeros in the machine code of the computer. And so all those virtual machines are many layers between you and the reality of the voltages and magnetic fields of the computer. And absolutely, that's probably right. In my case, I would be showing how the virtual machine is actually implemented by the specific network dynamics of the conscious agents, because I didn't mention this, but I'm not just one conscious agent, I'm two, and I'm actually in a whole network of conscious agents. When agents interact, they combine to form new agents. So there's a whole aspect of conscious agents I didn't talk about, but basically when agents interact, they also combine to form new agents. It's sort of what we call a scale-free theory of consciousness. And so what I call my body is just my icon representation, a very dumbed-down representation in my interface to describe the whole huge network of conscious agents that together interact to form the conscious agent that I call me. And so I would want to then say that all these virtual machines that we would think about in a computer science model of your interface are, in my model, going to be implemented by the various layers of this networks of conscious agents and how they interact to form new conscious agents. So this is agent-based modeling. A lot of mathematical modeling and interesting hard work to be done here. This is a whole fairly new kind of field of agent-based modeling that would be the right mathematics for this. So yes.
Wow.
Does that imply panpsychism?
No, in the following sense. I should say that panpsychism is a term that has many different meanings to different people who call themselves panpsychists. The most common meaning is something like atoms really exist, microphysical particles really do exist in space and time, and in addition, they have specific conscious properties. So an electron has a spin, it has a charge, it has a momentum, it has a position, and it also has a unit of consciousness. That's the standard way of doing it. So panpsychism, that version of panpsychism is either dualist or what they call neutral monist, but it takes, in some sense, the current laws of physics as sort of fundamental, right? Because what we have are the electrons and protons and so leptons and quarks and so forth, gluons. These things operate according to the fundamental laws of physics, but in addition, they have these properties of consciousness. And I'm saying something entirely different. I'm saying that there's this network of conscious agents that couldn't give a rip about space and time and quarks and gluons. It's doing its own thing. Quarks and gluons just happen in space and time, happen to be a particular headset that certain agents happen to use as a visualization tool, but it's nothing central to their existence at all. So from that point of view, there could be nothing further from my point of view than panpsychism. Now, there are others who will take a different point of view of panpsychism. They'll say, no, I just mean, so Galen Strawson, I mean, I've been in communication with Galen Strawson, and he said to me that by the word physical, he means just whatever the fundamental reality is. That's what he means by the word physical. And, and he's entitled to use that word however he wishes. I know that physicists don't use it that way. I mean, that's not how physicists use it. They have a very different idea. But he's willing to say that consciousness is the fundamental reality, and that's what you mean by physical. And I think that most people simply won't even understand that. But Galen Strawson calls himself a panpsychist, but he's more of an idealist in the sense that he's saying that consciousness is fundamental, unless Galen is also thinking that somehow the laws of physics themselves are also sort of fundamental, that these fundamental consciousnesses are interacting by these fundamental laws of physics. In that case, then I completely part company and say, absolutely not. The laws of physics as we see them are trivial aspects of one particular visualization tool that some agents use and other agents won't use. So that those laws of physics put no constraint on the nature of consciousness at all. So it's a very, very different view from panpsychism in that regard. I'll be having a fun discussion. I already have with a number of panpsychists, including Annika Harris. She and I've had lots of discussions over lunch for many, many months and so forth, going back and forth about panpsychism. It's a lot of fun. It's great to have people that disagree with you. That's how you learn. So.
All right, I guess we'll call it there. Thank you everybody so much for coming, and a lot of great questions. I hope everybody learned something. And thank you so much, Dr. Hoffman. It's kind of a dream of mine that you would be a guest of ours, so appreciate it so much that you came and talked to us.
Well, thank you, Danny. A very kind invitation, and thank you all for the great questions. It's been a lot of fun.
Thank you so much.
Okay.
Take care.
Take care.
Oh, if anybody wants to stick around for a bit and talk, you can feel free. We're going to stick around for a bit. All right.
Bye-bye.
Take care.
Bye.
Bye.